Okay, let's begin lecture. Uh, we're going to do some work today with the color luminosity charts, also known as the HR diagram. Um, New quote of the day person for the month of April is Benjamin Franklin. Uh, we're also I'm going to work and take a first look at your homework if you have something you want to show me. We'll do that at the end of class for a few minutes. Uh, but before we get your clickers ready, before we go any further, I want to trot through the basics of what we are doing. We're putting together a graph of the data, a color luminosity chart for the data. And just to remind you, there's the horizontal scale is basically the color or the temperature, and there's zillions of different ways to express that on a chart. You guys are using the spectral types OBA, F, G, K, M, and and each one subdivided from 0 to 9. But you could use the color, and I'm actually going to teach you a little bit about color index today, a little bit more on Thursday. You could use the temperature. Now, the temperature is not something that you observe, it's something you deduce by looking at the color. But sometimes you'll see a color luminosity chart with temperatures rated across the bottom. Your textbook has all manner of versions. The vertical is always some kind of a luminosity measure, whether it's absolute magnitude, and it could be absolute magnitude in a very specific filter, like the V filter, which we'll talk about today. The fancy name for it is color luminosity. The historical name for it is the Hertzsprung-Russell Diagram, or HR diagram. Here's another version. Sirius A is going to be up here. The Sun, Alpha Centauri, A and B are going to be kind of in the middle. And then down here is going to be your red stars, lots of them. Alpha Centauri C, Proxima Centauri. And here's another way to rate the luminosity in terms of the luminosity of the sun. So if you take the ratio of the star's luminosity and divide it by the luminosity of the SUN, then some stars will come less than 1, Sirius A, and other bright stars will come greater than 1. And the SUN and then Alpha Centauri A and B are going to be, the sun will be exactly at 1, and these other two guys are pretty close. They're very similar stars to our star, the sun. Now, up in the upper right of this diagram or of this slide, is a kind of a strategy thing. If we use the laws of physics and what we know of nuclear physics, so from Sir Isaac Newton, F equals ma, all the way to E equals mc squared and beyond, if we use all that, we can use a good color luminosity chart to figure out and model all kinds of things in stars in general. And so the color luminosity chart is a really good tool for analysis. Now, if you have your clickers ready, I have a clicker question for you, and I want you to really think carefully. And we'll talk about these color indices here. And let me start the question. I want to talk to you about it. Consider this like a question combo notes. If you have a star that's brighter in blue than it is in green, then that means it's pretty hot. Okay? It's pouring more of its energy into the blue. And if it's really hot, it'll pour even more energy into the ultraviolet. Astronomers use different filters. You know, just like Raise your hand if you do any serious photography and you use filters. Which, okay, just the TA. Okay, we go over here. If you, for instance, if you're doing black and white photography, film photography anyways, if you use a red filter or a yellow filter, it improves the contrast, especially for black and white. Um, uh, did you ever see those? Raise your hand if you've ever seen that infomercial on TV where they sell you these yellow glasses to use when you're driving at night. Ever seen that? And I think they're called blue blockers or something. Anyways, they got all these sunglasses, and they're basically filters. The yellow ones that they sell you are trying to, I guess, filter out blue or something, and let only the yellow through, and so that apparently that's easier to drive at night. I'm not really sure, but um, you know, so photographers, humans, civilians, uh, and astronomers. So the B filter, here's kind of the definition. The B filter, or capital B signifies the absolute magnitude when you look through the B filter. This diagram here, the UBV pass bands, shows you the wavelengths that the B filter is sensitive to. It doesn't look at anything else, or I should say, it looks most efficiently at stuff in this color band. And outside that band, it really doesn't, it's not as sensitive. Now the V band is kind of greenish. And so so if you put a V filter on your telescope and then you measure the absolute magnitude, you know, do all your parallax and all that stuff and all your logarithms, but for the V filter only, then you'll have an absolute magnitude in the V band. And so, so if you could do the same thing with the U band, that's theoretically that's ultraviolet. It's down here, the 400s, low 400s and high 300s, where that one's sensitive. So this question is about a star. All right, I see a bunch of you have answered. Good. You may want to. Which of these is plausible? B and V, 0 and -2, -1 and +1, 2 and 2, 2.2 and -2.2. So remember their magnitudes. So some of you guys might want to change your answers. I don't know. Seems like you. I'll give you another 30 seconds to answer. Demonstration. Let's see what you guys answer. Okay, 66% of you voted for that. A bunch of you didn't, though. So if you're in one of the other three categories, just make a note, and let me just go through it with you. B equals 0, V equals -2. Remember, for a magnitude, Smaller positive number or even negative means brighter. So this set here, option A, V equals -2. That means that the V band is brighter than the B band. Okay, so that's out because we know that the B band is brighter. So, and this is the true one. This is a negative. This is a positive. Okay, so the V magnitude, absolute magnitude, in the V band is up in the positives, and the B magnitude, absolute magnitude, is down in the negatives. So that's good. Now this one, B equals 2, V equals 2, that means they're the same brightness. So that's out. And then this one here, option D with decimals, is the same problem as option A, because this is a -2.2. There may be stars where this is true. Don't get me wrong. But if these are the measurements, you would say that it's brighter in V than it is in B. And the sun might have relative magnitudes like that. I'd have to look that up. But the sun is brightest in the green, and the V band is kind of greenish. All right. So here's some more information to digest. Okay, go ahead and make a note of this. The U, the B, and the V bands. Here's the central wavelength of each. Now, the central wavelength in the U band is slightly below 400 nanometers. And 400 nanometers, Charles, is like the generally agreed upon boundary of violet. So this is actually ultraviolet, which is why they use the letter U. And V here does not mean violet, it means visible. I don't know why they use these letters, but anyways, that's what they use. And then capital B does stand for, so this is a blue. This is 442 is kind of blue. And you could actually, there's websites where you could type in the wavelength and get the exact color of that light. They change it into RGB color or any kind of hex color you want. Same with this one, 540. Yeah, that's kind of green. And so it measures a little bit of blue and a little bit of yellow and orange, or excuse me, a little bit of yellow on one side, a little bit of blue on the other side, but mostly green. Okay, mostly at 540. And you can see they're dozens of nanometers apart. There's an R band. There's an I band for infrared. But the U's, B's, and V's, this is what we've got. And so my final comment to you, you should write this down. Comparing absolute magnitude of U in the U filter, so capital U, with capital B, the absolute magnitude when looking through the B filter, compared to capital V, the absolute magnitude when looking through the V filter. Those are ways to rate numerically the color of a star, because a hot star is going to be deep in the negatives over here for you. The B band, the B magnitude, is going to be not as negative. And the V band will be maybe up in the positives for a really hot star. And so comparing those magnitudes allows you to numerically rate the color of a star. Okay, and that's what's called a color index. And we're going to have some color indices in some of the next few diagrams, because I want to talk about the HR diagram in the double cluster. Now, those of you that have been going to, what day is the next, it's tomorrow night? And boy, if it was tonight, you'd have a stone cold lock one going. I hope the weather holds until tomorrow. We have really good dry air right on top of us right now, but there's no promise of that for tomorrow night. Anyways, for those of you that have gone up to the observatory, many of you have seen this pair of clusters. They're called open clusters. They're not globular clusters, but they're obvious clusters of stars. We think they were all born together. And so it's natural to measure the color and luminosity of as many of them as we can. And we have done that. And here's what the color luminosity chart looks like for one of the two double. I should have made a note which one this is. Anyways, you got a lot of stuff down here on the lower right and relatively few up here in the upper left. Now let's take a look at the scales. This is capital V. This is the absolute magnitude in the visible, in the V band, in the V filter. Okay, so they're using that alone as a measure of the luminosity. All right, and this is another way that you can use set up your luminosity scale, the vertical scale. Down here is a color index called C1. Now, I'm not going to go through C1 with you. I mean, you can look it up if you want. It's kind of fancy, but it's a color index, and it's basically comparing magnitudes in three different filters, or through three different filters. So this is blue. This is the blue end over here on the left at the zeros. This is the red end. Now, when you start graphing up your data on your national brand 12188 graph paper, you'll see it won't look exactly like this, but you'll think, oh yeah, I got a bunch down here in the lower right, and I got some up here, and I got some in the middle. So you'll start to see stuff like that. Here's the other HR diagram for the double cluster, slightly different. And this again is color index C1 across the bottom. So color, surface temperature, spectral type across the bottom. Use a color index if you like. Use spectral type if you like. Use temperature if you like. And what we're doing on the homework is spectral type. Anyway, so this is the double cluster, and what we're going to do is look at some other ones after we take a look at our HR diagrams. So what I would like you to do right now is, if you have something that you want me to check, I want you to bring it up and pile it up here on the desk, and I'll look at it, and I'll talk about it with you. Come on up. The assignment's due on Thursday, but if you have something you want me to look at, just to verify what you got, you can show me what you got. Okay. All right. Let's take a look at this. I better turn off my mic so I don't blab out it to the whole classroom.
I wasn't here on Thursday.
Yeah.
So I didn't get
It's right there. See that?
Yes.
That's the order. Okay. So, and just follow the instructions. All right? Great. Okay. All right. Well, notice you use 2 blocks per spectral type, right?
Yeah.
Yeah, that's good. I think that's what I'm going to recommend for the rest of these guys. This is great, this paper. In past semesters, I didn't recommend any graph paper. And we had, that student that just had that engineering paper. To do it on engineering paper requires about 8 pieces taped together. So I would get this homework assignment, like 30 people with these big rolls of paper that, But this, you can get it all in one. This looks pretty good. Sirius, Polaris. Okay, see if you can look up the sun and part. It's going to be in here somewhere.
All right.
And your scales are looking right. It's good. Good. You're just about ready to turn that in on Thursday. Let's take
I
a
did
peek.
mine in color too, but I think you got the colors upside down. have red down here.
Ding.
Yep.
Yeah.
I'll flip that around though.
You mean
And
you're
then-
going to do it over again?
Yeah.
Okay. It's not that hard.
Well, once you get the scales, and you said every two for the.
Yeah, I think so. You think?
Yeah, I did mine
Is
by
that-
one, and it's just
Yeah, it's kind of steep. This looks a little bit nicer.
yeah.
I'll do
Actually,
every
can
two.
I keep yours up here in the front?
Mine's not correct because I don't have the every two.
It's not?
I don't have that.
Yeah. Oh, you don't have every two?
Yeah, that's what I have to change. Or just tell me.
Yeah, Betelgeuse, good.
You said the sun too.
Polaris, yeah, and get Alpha Centauri, our nearest neighbors. Okay, anyways, that's looking pretty good.
Thank you.
All right.
Yeah,
Next.
so I'm gonna change mine to be every two and then do graph.
All right, now I want you to write down absolute magnitude capital M over there. All right, and down here spectral type, and you've got the letters, so that's all right. And Proxima Centauri, Partner, it's good. And the sun's going to be up in here.
Yeah, I put the
Oh,
sun up there.
no.
I googled
That's-
absolute magnitude,
Yeah,
and it got weird.
it should be
It
about
was
4.8 is what I have.
Yeah, I
for the-
found it.
Yeah, 4.8.
4 point. And then
Sweet.
G2.
Yeah, see, right next to Alpha Centauri. Exactly. 'Cause they're like
I took a
cousins.
shot in the dark, and then that happened. So I was
Fail.
like- I know. I was gonna ask you. About
No,
that.
it's in pencil though, right?
Yeah. Well, I have to regraph it.
Yeah. Well, your scales are looking good. Double this, and it'll look really sweet.
Yay. Okay. Cool. Thank you.
Yeah, see, battle tested. Okay, so Betelgeuse and Antares. This is 2. This is incorrect. Okay. Your absolute magnitude scale is supposed to be positive numbers at the bottom. Oh, wait a minute, that's what you've got here.
I'm sorry. It is the racing. That's positive and negative.
Oh, you did 10 blocks for every 2. I see you're doing evens. Yeah, see, I do 10 blocks for every 1. So I started down at 16, and up here I got up to actually to -9. So that'll stretch it out. So that'll put Betelgeuse and Antares a little bit higher up here. Okay. And so this actually is okay over here. Right in the words absolute magnitude.
Okay. And then you're doing 2 down here.
Yeah, I think 2 is that what you've got? No, you've got every 2. No. You're every, I don't know what you're doing down here.
I need to make that better.
Yeah. You know what? I'm gonna see if have you got any extra paper? Can I borrow a piece? And I'll pay you back. Okay, well, let me look at your homework first. Ooh, I don't like all these vertical lines.
Oh, I know. I'll erase them. It's just to help me.
Yeah, I know, because you like
I
totally
need
need
like
a
a magnifying,
microscope, you
yeah.
know.
I'll erase
But you know, the thing is, normally you do this on a computer, but it's good to do it once by hand, just so you know how it all works. So this looks pretty good.
I had a question though.
Yeah.
Like, like right here, like I started like 1 over and 1 up is better.
Yeah, I think so. You have enough room,
Right.
right? So yeah, this paper gives you plenty of room to have a good big graph. So it's not all crammed down into one corner, or the other way. You don't need like 8 pieces of paper. Like you should have seen. I've got one in my office that was pretty nice. It was 4 pieces of paper, but I've had them, like this big, literally. By this big, like 16 pieces of paper. It's unbelievable. But this is great. All right. And could I borrow this?
I just had a question. I'm not gonna order those things.
Do you want to turn it on? You sure can. Ow! This is so good. It's actually hot. This is fireproof paper, obviously. No, I'm just kidding. This looks good. Oh, no, it's, and you used yeah, that's good. I'm gonna recommend that. Yeah, K0, K5. Actually, can I keep this up here?
Yeah, I'm turning it
So,
up.
yeah, you're turning it in. Good. All right. Well, thank you for that. And I'll use yours as an example. Okay. Okay. Instead of this baby, this thing's been through the war. Clipboard. A little clipboard action here.
So I haven't labeled all of those for the label yet.
You got all your dots here. Yeah, label this absolute magnitude sideways. Spectrotype's good down here. And if, I don't know, this is all right, but you know what I'm going to recommend is this horizontal variation, two blocks per spectral subtype.
That was
It
my
just,
question.
yeah, it extends it out a little bit better. But I mean, this is acceptable. So this one will be, you know, this one is going to look a little bit more. It's good. The more spread out it is, the more useful it
Yeah,
is.
that makes sense.
So
So for the 6 stars you indicated on the instructions, are those the only ones we need to label? The 6
yeah,
you
or
gave?
if you have a personal preference for one of the other stars, you know, like just don't label all of them.
Yeah. And also, we're not required to find
If your uncle is actually from one of these other stars, your weird Uncle Harold, you know, and you want to, you think highly of him,
Yeah.
then you can label that star on there.
Yeah.
These are good.
We're not required to find the sun.
You're not required, but you better do it. If Dr. B says to try it, that's kind of, it's not really a hint. You won't be marked down for it, but you might want to have it so you can use it on, because we're going to be using these on the exam, final exam. So, I mean, it's not like, you know, it's not like you're just doing something to do it. You're going to be
Just
using
looking
this.
at it, I know I'm like wrong because I did it starting
Yeah.
negative.
Do you want to do it? Oh,
Yeah, so I have to like switch it and then do it bigger.
yeah. But the horizontal, okay, I'm going to use this. The horizontal looks good, or the, oh, this is upside down.
Yeah, exactly.
Yeah,
I have to
so,
switch it.
yeah, so this
But I
should be up
understand now,
here,
'cause I
and
was
this should
gonna
be
ask
down.
you
Yeah.
if it's supposed to be that tight.
Yeah, so your Betelgeuse is right over here.
Um,
Good. I'm going to start, I'm going to use this blank to start graphing,
okay.
and just so everybody else can see how to start it. Okay, and you can take notes. Anyways, you'll be ready for Thursday though, right? Good.
I have more of a general question because I was too scared to start, but I've been like mapping it out on regular paper, but it was
What
pretty
is
much
your
what
name again?
Brittany.
Brittany.
But with
I keep forgetting. Dude, you can't turn that in. That's blank.
I know I'm too afraid to start. I've been practicing just on like my but
I tell you what, watch me. I'm going to start with this,
okay.
and then I'm gonna start in a plot 1 and 2.
Because my question
And-
was for the horizontal axis. Because I know like for
The
this
hor-
one I should start 16 and kind of go up.
Yeah,
With, like-
just like this one.
Isn't it one per? Oh.
It
yeah.
was on the handout. I said go 1 block per spectral subtype,
'Cause there's
but
too many little
actually
sections.
this girl and a lot of other people went 2 blocks.
Because we separated with 0 to 5 and then did it like
Yes,
every 2
so
lines.
yeah, so
there's,
0
like,
to
2
5
more.
is 10
Okay.
instead of 5 blocks, and you've got enough room for it, so why not?
Yeah.
So, alrighty.
Okay. Thank you.
So I'll take.
Some of the students are asking for graph paper and the worksheet to put those
Yeah. I don't have the worksheet and I don't have graph paper.
Oh, okay. I
But
gave them one. I have
I'll
one.
review the procedure in
Okay.
just a second.
Okay.
Okay, let's get back to. Okay. Let's get back to Um, let's get back to lecture. I've looked at a bunch of your guys' homework. Some of them I really liked. We're going to go on the document camera, but before we do that, I just want to remind you that there is a web courses homework assignment for calculating wavelengths and temperatures using the Wien displacement law. And I know a bunch of you have tried it. I want the rest. It's due Thursday at 1:30, so I gave you an extra couple days to work on that. So get in some practice with that. And then the graphing homework. I'm going to conclude the podcast